So we're going to go on to the Clear Edge. Ian Chisholm of Clear Edge, I see is the presentation going to be made from your phone, Ian?
Sorry, Bob, I'm on the phone as well. Richard Light. So I'm
okay. Who's going to be making the presentation? Because we'll unmute that phone.
I'll be making it, Richard Lyden.
Okay. Now we need to track down your phone number up here. There's numbers by the phones. See, so why don't you say something again, Richard? Just give us a little bit of your background. While you're doing that, I'll track down which phone you're on.
No problem. I'm Richard Lyden. I work with Clear Edge Filtration worldwide.
You're on caller 24, Richard, so I'm going to put everybody else on mute and go to your presentation and and then you can give us a little bit of your background again and then get into the presentation if you would. Thanks.
Sure.
Okay, and so we'll mute all, and then we're going to unmute caller 24. And Richard, are you unmuted? Can you say something?
Can you hear me?
Yeah, we sure can. Okay, so we're all set then, and we'll then go to your presentation.
No problem. Thank you.
And I would assume we would be the PDF. I think it's this one right here, which is the others are a couple brochures on the products, but I'll bring up the PDF here, and I think we're ready to go.
That's right. Thanks, Bob. Yes, as I said, we're involved in industrial process filtration. My name is Richard Lyden, and I'll give you a few slides on an overview of Cerafil, which is a ceramic for hot gas filtration. A couple of my colleagues are on the line, including Dr. Ian Chisholm and Mark Daniels in the US. So if you go on to the next slide, Bob. Just a little bit about Clear Edge. We're an industrial process filtration company, mostly selling filter media and engaging mostly in solid liquid separation, but also dewatering, collecting, and air filtration, including the purification of hot gases in niche industrial applications. Next slide, Bob. We're a worldwide organization. We're about 1,100 employees operating across the world with 13 operations. We have three main plants in the US and one in Mexico. Next slide, Bob. Today I'm just going to give you an overview of the ceramic filtration technology and its particular duties, and finish up with some case studies. We manufacture low-density ceramic filter elements that are used for air pollution control, product recovery, and product collection, and mostly developed out of tightening environmental legislation, new filter plant installations, baghouse retrofits, and ESP retrofits. Next. Ceramic filters themselves are very highly efficient. As I said, they're made out of a low-density ceramic material, aluminum silicate fiber. They have efficiency of less than 2 milligrams per cubic meter, which is extremely efficient. So they can handle submicron particles. They have high temperature capability up to 900 C. They're corrosion resistant. They're because they're ceramics. They're reasonably light. They're about 80% to 85% air, and they're highly permeable. And they work well in conjunction with dry scrubbing agents. We'll come on to that a little bit later. And they're effectively a mineral fiber catalyst product, and up to 3 meters long by 150 millimeters diameter. Next. They're rigid candles, which can be employed in fabric bags and filter plants. They're capable of operating up to high temperatures, including in process or alongside other processes. They're on the market since about the mid-80s, 1980s, and we've got hundreds of references now worldwide. Next. The properties themselves, they're a ceramic or mineral fiber composite material. They're rigid, so they don't need any other support mechanism. They're of a highly porous structure. The top picture on the left there is an SDM of the fiber structure themselves. They're bound together in a structural format. They're a one-piece construction. The photo on the right shows you the actual elements themselves. There's a closed end at the top and open end at the bottom, and they're self-supporting, and you can see an array of them in the bottom photograph there where they're hanging from a tube sheet. Next. The filter efficiency mechanism works by virtue of a gas flow which flows from the outside of the element towards the inside of the element. They have a high filter efficiency, a negligible depth penetration, so the actual small particles cannot get inside the wall of the structure or the element wall. They can be handled in variable conditions, and that gives them a potential for long life. In long life, we're talking somewhere in the region of 4 to 5, 6 years, depending on the application. There's a efficiency test we use, which is a VDI, which is fairly well recognized, 3926, and we have a test regime we can set up, including cleaning cycles, pressure differentials, inlet gas conditions, clean air conditions, etc. So there's an example there. And the image on the bottom shows the gas flowing from the outside with the dust cake buildup, the residual there, and then a reverse pulsing mechanism happens periodically so that dust layer is cleaned off and the whole cycle starts again, and the residual layer will remain. Next. The benefits of high temperature filtration is that you move away from effectively from limited bag, the limitations of filter bags, which is effectively around, I think, the 200 degrees centigrade mark or 400 F. Reduced requirements for dilution effectively in smaller plants. Avoids also the acid dew point, so minimizes your plant corrosion, and very effective in acid gas scrubbing. And of course, then you have a maintained temperature if you're up around the 600-800 F level, certainly for DNOx, SOx, NOx, ROx, etc. So you can start to then treat those type of gases, and we'll give you examples of that in a few minutes. And there's also potential for heat recovery for clean gas and increased stack buoyancy, which effectively is very important in power plants. Next. We have 3 products in the range. The XS is the earliest one, going back about 15 years. We have 200 successful references worldwide on this. The green is a bi-soluble fiber. It's got excellent strength to performance ratio. And the last one is a TopCat, which is a combination of particulate removal with dioxin and NOx control as well, and is a solution for stringent emission control legislation, which I'll give you some examples of in a few minutes. Next. Effectively, the Serifel TopCat is a combination of the Serifel XX technology, which is effectively the filter themselves, as shown there in an array in a filter plant, combining it with SCR, which is selective catalytic reduction technology. So you combine those into there's two well-established technologies into a new technology, and you effectively got Serifel TopCat. So effectively, you're taking 2 very well-known technologies and bringing them together. And we developed this over the last 8 to 10 years, this technology, and we've now got operational plants worldwide. Next. And this gives you the ability then to be able to put a filter plant together, the typical filter plant, with the elements inside, and you can then treat mixed pollutants by injecting ammonia or a reactive material or lime, and you can then start to take out dust, but also then start to remove other contaminants like nitrous oxide or DNOx or SO2. Okay. Next. And how this works is that we have distributed the catalyst throughout the wall of the element, and the top picture, shows an SCM, a scanning electron microscope, graph of the nano-sized catalyst particles inside in the filter itself. You can see the fibers there in the SCM, and along the fibers there are nano-sized catalyst particles. And the bottom picture actually shows an elemental detection graph of the catalyst distribution along the whole width of the element. Next. This is a typical filter plant configuration, which includes working from the top, your manifold and your plenum area, your element inside, your box itself, which includes your gas inlet, and then your just outlet or your valve at the bottom. So a typical, I would say, what you would call pulse jet filter unit. The elements themselves, there's a little bit of an exploded view, so you can see where the elements sit. They more or less sit in the same way as a traditional bag filter would sit, but unlike a bag filter, there's no inner cages. These are, as mentioned, self-supporting. There's a little bit of a different design in terms of the way they're put at the top, but if you move on to the next slide, Bob, I think there's a little bit of a view of that, which includes the clamping element and cleaning system. So we have on the top left picture, you can see the gasket which seals the element, the elements themselves in the distance in an array of 4, and then the clamping tube sheet that goes down on top, manifolds in on the right which go on top of that, and then the unit is closed. And generally when the unit is closed up, unless something disastrously goes wrong, the unit should perhaps operate, if it's operating in a well-maintained plant, should operate for anything from 3 to 5 for 6 years, depending on the application. Next. We're involved in applications such as cement, chemicals, diesel engines, gasification, glass furnace. That top picture on the right is a glass furnace plant, metal smelting, mineral processing, sewage sludge incineration, which is a picture on the bottom in Japan, and waste incineration. Next. Just a few case studies to sum up. This is one of the early case studies we got involved in, the meat waste incineration plant in France, where there are 80 TopCat 3-meter elements in place, 112 square meters of capacity at a 220 degrees centigrade. We look at the inlet concentration of O2, the NOx inlet, the phase velocity, the pressure drop, and these are some official tests that were done in November 2005. So this is a combination of a ceramic element with a catalyst inside. So combining, let's say, the filter capacity with the SCR technology, which is effectively TopCat technology. So we're removing dioxins and particulates down to the very low nanograms per normal cubic meter level for dioxin and particulate level at 1.2, 1.1, and 1.8 milligrams per normal meter cubed. Next. This is a clinical waste incineration plant in the UK with 270 TopCat 1-meter elements. Again, a little bit on the gas flow. The temperature this time at the bottom end of what we'd be looking at, but it just shows also that we can control dioxins at this level. Dioxin removal efficiency of 99.2% and the dust removal efficiency of 99.9%. Next. This is a smelting plant in South Africa. We've got 10,368 elements in this of a particular type. This was installed in 1998. Still operating today. Those of you who know smelting plants would know that these are usually on a very large scale. So a platinum plant. And this has been operating since 1998. Okay, next. An asphalt reclamation plant in the Netherlands, 2,640 elements here, 3 meters long, operating since 2006. Next. Recently installed glass furnace plant, a new area of application for us that we're developing also in the US, installed in 2009 in Spain with 1,900 elements inside, 3 meters long. Next. This last one might be of interest to all the people in power online. This is the new latest technology, waste to energy technology out of Sweden. Some of you may or may not have heard of LATI, the LATI energy project in Finland. This is the first in the world to be fueled by clean glass from solid recovery fuel. And solid recovery fuel is typically the material that cannot be recycled, like waste plastic, waste wood, paper products, etc., unsuitable for recycling. and the material is fed in. There's a little schematic on the plant is on the top there on the right. In the bottom, you can see the schematic of the element itself. Of the plant itself. There are 2 times 6 filters here, 4,000 elements, 2.25 meters long. And the gas comes in at around, the SRF fuel is heated at around 900 degrees centigrade. The fuel itself is not burned, it goes through a hot sand fluidizing bed, conditioned in and recirculating system, which then becomes gasified, produces the fuel gas for the power generation. The bedded material itself is untreated, so it goes back through then a cyclone and then goes into the filter plant itself, where the gas is cleaned, and typically the styrofoam elements will take out unburned carbon, condensed metals, because you will get some metals in this process, and solidified chlorine and ash. And the contaminants then fall into the bottom of the stream and collected, and then the process is cycled again. And this plant produces somewhere in the region of 50 megawatts of electricity, 90 megawatts of district heat, and is the first eco-clean gas producing operation, I believe, in the world. Some rates there for you in terms of the SRF rate. The SRF rate of 360 cubic meters per hour is about 250,000 tons, which corresponds to around 170,000 tons of coal per year. So that's typically the feed-in rate. Boiler working at 440 C, pressure of 121 bars. So this is a brand new technology, which I think is a very interesting waste-to-energy technology, employing styrofoam to produce the clean gas. Okay, I think that's nearly it, Bob. Thank you very much. The styrofoam Topcat won the ICME Award 2005 and is now an available technology.
Very interesting. I'll ask a question or two and then turn it open to the floor. A lot of the older utilities in the U.S. are faced with retrofitting. They have precipitators, and they're faced with retrofitting new fabric filters, possibly, and SCR. And what you're basically saying here is they don't need the big footprint to add 2 pieces of equipment. They could replace their existing precipitator, with the combination of the Topcat unit, and at the very least get the NOx and particulate out at levels they're probably not getting with their existing precipitator.
Correct, Bob. Yeah, this is a simplified 1-unit process. It's all built into the same unit, so you don't need a bag filter, you don't need an SCR, you don't need your ESP or your SCR. You just need 1 filter, and this can do the whole lot for you, including giving you high temperature control, so you don't have to cool your off gases, and also effectively controlling a lot more of your process inline, but also simplifying the whole train and making it much more cost effective to operate the whole plant.
And I know a lot of coal-fired power plant operators on the line are thinking, okay, well, what about the maintenance? I'm having a problem with my SCR plugging now. What happens if instead of an SCR, I've got some combination like this? And I think what you're saying is your ability to keep the particulate from penetrating the interstices is actually an advantage rather than a disadvantage, and you would therefore expect less buildup and pluggage than you would be had you were just operating the SCR by itself. Is that a fair characterization?
Correct. In a lot of cases with SCRs, you have to have some type of abatement technology up front in order to protect your SCR anyway, or you should have. Otherwise, you will poison the catalyst over time. And I think with the ceramic filter elements, you effectively have embedded, as I said, the catalyst inside the filter it's a very fine residual dust layer, residual layer we've got on the outside of the filter, and that keeps all the very fine particulate on the outside, so it doesn't allow it to penetrate inside into the filter itself. So you're effectively using the tubes, the catalyst filter tubes, the filters themselves to protect your catalyst. And give you two benefits: one, long life of the filter, of course, but two, long life of your catalyst as well.
Yeah, I think that's very important because there are a lot of catalyst poisoning problems, and ultimately the only protection that has been installed is what they call the popcorn screens to just get the very, popcorn-sized fly ash out. So. And what you're saying here is you're allowing or preventing the very small particles even from penetrating into the catalyst layer.
That's correct. Yeah, we have scenarios in glass plants, and now in this plant in Finland, and we've got plants in France and in Japan, where we have very small, very fine particulate operating in very quite difficult conditions. And we're preventing those very fine particulates from getting inside the filter. That effectively gives you both very fine filtration, but also gives you a long life of these filters. And that's one of the secrets of this technology here.
And then you mentioned one other aspect which could be huge, which is you're essentially having gas that's cleaned of particulate at, say, the 850 degrees where your Lungstrom air preheater would normally operate. And now that you're using clean gas rather than dirty gas, you can eliminate the inefficiencies of the Lungstrom air preheater, the leakage and all these other aspects, and go to a more efficient heat exchanger. And, if this were to save you 1 or 2% in boiler efficiency, or even a fraction of a percent, I think you're going to be closer maybe to 1% anyway. That's a very, very substantial increase. If you go from 38 to 39%, that's several percent net increase or reduction in CO2 emissions.
Yeah, the case in Finland now, which is operating for about 1.5 years, 2 years, the Therafil filters are actually employed to remove substances such as, in this particular case, alumina, copper, chrome, lead, nickel, alkali metals such as sodium and chlorine, which could wear out your boiler parts, such as also your heat exchanger. Yeah. So effectively, yes, you are actually protecting that as well. So that's a side benefit of the technology. Yeah.
Well, it certainly would greatly change the way power plants operate, and I'm sure there are going to be a lot of questions and interest. I'm going to unmute all here and see if we have a few questions. And if we do, we can take some time with them. Otherwise, we'll move on. Questions from the floor.
To break this out up here.
We are hearing somebody talking there, but I'm not quite sure. Let's see.
Hello, this is Dave Stopek at Sargent & Lundy. What do you do if there's a crack in one of the candle filters? Do you have any devices internal to prevent leakage?
Yeah. Usually we have. Usually there is a detection process. Usually in these filter units which are well established, the existing filter units, there's a flow control mechanism either upstream and downstream of the process, and you usually have a detector, usually on your outlet gas, so you can tell, let's say, straight away if there's a leakage or a breakage or something like that. A breakage would only occur in situations where perhaps you're operating perhaps in a very difficult environment. We're actually operating in some locations in Japan where there's earthquakes, and I think we have the most amount of installations in Japan, and as you know, that's very susceptible to earthquakes, etc. And we've actually developed some filters there which are specifically bespoke for Japan conditions. And again, we've been working with them in terms of putting detection equipment upstream and downstream of the process line with OEMs involved, so people like yourselves or equipment builders.
Other questions from the floor? Well, it's a radical departure, and what you're offering is a very substantial potential improvement in the footprint requirement and performance, et cetera. What kind of and obviously you're comparing it to an SCR and fabric filter combined, or in some cases to an SCR, a fabric filter, and a scrubber if you use the dry injection along with it. How does this compare to other particulate removal devices? Is it twice as expensive on the average, or what are we talking about here?
If you look at Bob, if you look at the overall, let's say the simple 1-unit process device, I think we did some work maybe 2 or 3 years ago on this. I haven't done a huge amount of work on it, but effectively, if you take, let's say, your the SCR technology, your existing filter technology, your barrier technology, which might be an ESP or your baghouse, it is probably overall the cost of ownership of this overall is much more inexpensive as opposed to those technologies. The technology itself is a little bit more expensive than let's say your high-end bags, which you would normally use, but you'd normally be replacing your bags perhaps every 2 or 3 years. You'd be going in actually doing maintenance on that as well, of course. So you can actually put this on if you maintain temperature and you maintain conditions and you're reasonably. And in some of those plants I've shown you, some of those are not the most easiest plants in the world. Certainly platinum isn't the most easiest. Refineries aren't the most easiest plants in the world to operate. You certainly can make the filters last. At least we've got filters lasting 3 years to 6 years in operations worldwide. So your cost of ownership is effectively quite good, and your effective maintenance program is also improved because of your effectively simple unit process controls.
And again, you're comparing, your candles versus the catalyst and the bags with alternative.
That's correct. Yeah, I think if you have an SCR in there, you'd have to have some type of protection up front of your existing catalyst anyway. Your SCR, you're probably some type of barrier technology in order to protect the particles penetrating into your SCR.
Other questions? Okay, well, I think we'll move on. I want to